Okay, YouTube, this is my first video in which we're going to introduce the notion of solving a triangle. And specifically, we're talking about right triangles in this module, but essentially, when you are asked to solve a triangle, what you're asked to do is find all the missing measurements in the triangle, just all the measurements. And so what measurements exist? Well, we have 3 angles and, of course, 3 side lengths. And so using the given information, really, it's our job to go find the things that we don't know. And I do want to point something out. Since we are discussing right triangles, in terms of this right triangle right here, we already know one of the angles is 90 degrees. And it's worth mentioning here that all angles, when you sum them up on any triangle, have to add up to 180 degrees. So I do want to mention this. If 180 degrees is the sum of these 3 angles right here that you see on this right triangle, 90 of them lie right here at this right angle, then this 60 plus this other angle, they have to add up to 90 as well. And so that being said, it is worth mentioning that the 2 acute angles on any right triangle must always add up to 90. That is, these 2 acute angles must always be complementary to one another. So we say in a right triangle, acute angles are complementary. So I only mention that because if we're going to solve this right triangle, if I can spell complementary correctly first, if we're going to solve this right triangle, the first thing I would do is I would go find the value of this other angle if possible, and we certainly can in this instance. It's a 30-degree angle, okay? So now our job here is to use what we do know, which is this side length and these 2 angles, to go find the lengths of these other 2, in this case legs. And I do indicate that I wanted to start with this value of x first. So let us look at this and we say, okay, well, what we need to do here is this. We need to choose a trig function, sine, cosine, or tangent, that is going to allow us to compare one of these 2 angles. I'm going to go with the 60 for now because we were hooked up with the 60. But essentially, compare this 60 to 2 of the side lengths on the triangles. So we want to set up a situation, though, where we know 2 of these measurements and the third one we don't know. So since I don't know x, I'm going to try to compare it to an angle on another side on this triangle that we do know, and we do know this 60 and we do know this 10. So my question is this: with respect to this 60-degree angle, what trig function could we use that with respect to the 60-degree angle compares this side here x to this side here 10? And I would say, well, since the x lies across from this would be opposite, and this is the hypotenuse, we say opposite over hypotenuse, this is going to be our sine trig function. Okay, so we could say that one comparison that is useful here is the sine of 60, which we know that angle, is equal to the opposite length, x, over the hypotenuse length, 10. Okay, so you'll notice in this equation here there are 3 values, the sine of the angle, x, and 10, and of all of these 3 things there's only one we don't know. So this allows us to use algebra to go solve for this angle measurement here. And so I want you to notice this first. We're going to say x equals 10 times the sine of 60 degrees. Now we're going to use a calculator to determine the approximate length, but we're also going to say that the sine of 60, as a matter of fact, is a value that we should have memorized. And so we can find not just an approximate value, but what we call an exact value. So first things first, we say that the length of this leg down here is exactly 10 sine 60. I'm going to call this an exact value. Because we haven't given a decimal in which we've rounded this, we say that it is exactly this long. Furthermore, when we talk about the sine of 60, we say, well, the sine of 30, the sine of 45, and the sine of 60, these are 3 values. That's a 45. I'm going to go ahead and fix that for 45. And the sine of 60. These are 3 values that we should have memorized. I'm just going to go ahead and say that. You know, don't take it the wrong way if you don't have them memorized. It just means make flashcards if you don't. Because they all have something in common. They're all over 2. And from 30, 45 to 60, it just goes 1, 2, 3. And you'll notice I didn't put a root over this one, but you could. You could if you wanted to. So we say the sine of 60 is root 3 over 2. So we really get 10 times this value, root 3 over 2 is x. And we'll put this 10 over 1. All of trig is always ratio math or fraction math. So we're going to put this 10 over 1 and multiply straight across, and I notice that my 10 and 2 cross reduce. This becomes a 5 and a 1. So the length of this leg up here is 5 times the square root of 3. 5 times the square root of 3. When you solve a right triangle, it is always best to go fill in the information that you've just determined, okay? So this makes sense that I would want to go do this here. So now that I know that this is 5 root 3, I say, well, how could we go and solve for this other length over here? And let's just call this y. Well, I have 2 options. At this point, we could use the Pythagorean theorem that says x squared plus y squared is going to equal our hypotenuse squared. and I could throw in this 5 root 3 here. And remember that when you have a product to a power, you have to take both parts of this product to the power. So we say 5 squared is 25. The square root of 3 squared is just 3. This would be plus y squared equals 100. And we could say, well, we have 75 plus y squared equals 100, really. So subtracting 75 from both sides, it follows that 100 minus 75 is 25, and therefore it follows that y equals plus or minus 5. And since we're solving a right triangle, we'll just call this 5. So I could take the time to write a 5 up here. And you know what? This makes sense. Obviously, this is a 30, 60, 90 triangle. And to point this out to you, the short leg on the right triangle that is a 30, 60, 90 is half the length of the hypotenuse, or the hypotenuse is double that. And then the long leg is the short leg times the square root of 3. So we could have inferred this anyways, but using Pythagoras we could solve for this, or we could use another trig equation. So that is to say, if I knew these angles, and I don't know this is y, and I know the hypotenuse is a length of 10, we could say that, for instance here, the cosine of 60 would compare the adjacent side to the hypotenuse, where we have the cosine of 60 degrees is equal to our adjacent side, which is y, over the hypotenuse, which is 10. So now taking both sides of this times 10, we could say that y has an exact value of 10 cosine 60 degrees. Okay, and the cosine of 60 is the same as the sine of 30. It was backwards from our sine values. So we get 10 times a half is y, and so we get 5 as y. Half of 10 is 5. And of course, that's what we're able to determine using Pythagoras or our special relationships with these sides of these triangles. So I did say we were going to use a calculator, and so for instance here I did want to show us this. Now, knowing that my calculator is in radians or degrees mode is important. We are not in radians. For right now, you just need to know that you are in degrees. And if I were to have typed in cosine of 60, I have to do this. I have to say 60 cosine, you get your half value there, times 10. We could have gotten this 5 that we got here. Now, in this particular instance where we had 5 root 3, I want to point this out. If I take the square root of 3, square root of 3 is this number here, approximately, times 5, I would have gotten about 8.66-ish. That's how long this bottom side is, and that's reasonable. It's just that that's an approximate value. It's not exactly what we want. So I could have typed in 10 sine 60 into my calculator. We say 60, take the sine of that, take that times 10. You notice that we get that value right there. Okay, it's just that this thing right here that we're calling an exact value is often what we desire the most. So exact values often include roots on them. We say 5 root 3 is an exact value. And moving forward, we're going to say sometimes that x is approximately 8.66, maybe feet or inches or whatever. But this right here is just an approximate value. So be careful when somebody asks you for an exact value. They mean that they do not want this decimal. They want exactly 5 root 3. Cheers.